Welcome back, explorers of the unknown. Today, we embark on a journey that pushes the limits of human imagination and reaches into the deepest mysteries of our universe. What you are about to witness is more than just science. It's a revelation of cosmic forces so massive, so powerful, that they reshape everything we thought we knew. So take a breath, settle in, and make sure to hit that like button and subscribe, because this adventure will take you across worlds, through storms of light, and into the heart of phenomena far beyond Earth's horizons. Prepare yourself. The universe is about to open its doors.
To imagine how long it would take a person to travel once around Jupiter's glowing aurora, we must first understand the scale of the planet. Jupiter is a gas giant so large that more than 1,000 Earths could fit inside it. Its magnetic field stretches far into space, shaping the brilliant auroral ring around its poles. Unlike Earth, where auroras dance along high-latitude skies, Jupiter's auroras form massive, continuous ovals of shimmering light. These powerful displays are fueled by charged particles from volcanic plumes on its moon Io. They never fade completely, creating a permanent cosmic halo around the planet. To circle this auroral ring, a traveler would need to follow the magnetic boundary where the glowing light forms. This path is not a simple circle, but an immense loop shaped by Jupiter's rotation. The planet spins faster than any other in the solar system, completing a day in just under 10 hours. The auroral oval itself stretches thousands of kilometers across. If a person attempted to walk the entire perimeter, ignoring the impossibility of standing in Jupiter's atmosphere, they would be facing a journey far greater than crossing any place on Earth. The scale alone makes it nearly unimaginable. Suppose this journey were possible by moving along a stable orbital platform, tracing the auroral boundary. At a comfortable human walking pace of 5 kilometers per hour, the traveler would take an eternity. Jupiter's auroral circumference could exceed 100,000 kilometers, depending on altitude. At that speed, completing the loop would require more than 2 years of non-stop walking. But traveling in space rarely happens at such slow speeds. If the traveler used a small spacecraft capable of maintaining a stable magnetic orbit, the situation would be very different. A modest craft moving at 1,000 kilometers per hour could complete the auroral circuit in a few days. Yet the magnetic forces near Jupiter are incredibly strong. The craft would need advanced shielding to survive radiation levels hundreds of times higher than Earth's Van Allen belts. Even with protection, navigating the auroral ring would be challenging. Charged particles swirl constantly, creating bursts of radio waves and violent interactions with Jupiter's magnetosphere. The traveler would experience a journey filled with constant electromagnetic storms. Assuming safe passage and steady velocity, the time to complete a full loop around the aurora might be roughly 3 to 5 days. This estimate accounts for variations in the magnetic boundary and the need to occasionally adjust course around turbulent regions. During this trip, the traveler would witness colors far brighter than those on Earth. Jupiter's auroras shine in ultraviolet and infrared wavelengths, invisible to human eyes without special equipment. Through enhanced visors, the sky would appear like a colossal electric river of color. Each moment would bring new patterns of swirling light. The aurora would pulse, stretch, and ripple as Io's volcanic activity surged. Electrons hurled along magnetic lines would collide with Jupiter's atmosphere, painting the darkness in vast arcs of radiant glow. Though the journey would last only a few days, the psychological impact would be enormous. Floating beside a storm-filled giant surrounded by cosmic lightning and magnetic fire would make the traveler feel both insignificant and deeply connected to the universe. As the spacecraft continued its loop, Jupiter's rotation would cause the aurora to shift beneath the traveler. The planet's fast spin would constantly reshape the magnetic field, altering the glowing oval and creating a dynamic path to follow. Far below, Jupiter's clouds would churn with storms larger than continents. The Great Red Spot, a centuries-old hurricane, would occasionally drift into view. The traveler would see swirling bands of color unlike anything on Earth, each adding drama to the voyage. Despite the beauty, danger would always be present. Radiation intensity could spike without warning. A protective hull would hum with charged particles. Alarms would sound as the craft's systems compensated for magnetic fluctuations, twisting the navigation field. Reaching the halfway point, the traveler might reflect on the scale of the undertaking. Circling such a massive feature on an alien world highlights how monumental Jupiter truly is. Even a few days in this environment would reshape anyone's understanding of nature. As the final stretch approached, the aurora would grow even brighter. Particle density increases near certain magnetic nodes, creating bursts of light that flash like celestial fireworks. The last hours of the journey would be the most visually intense. Finally, after days of constant motion, the craft would return to its starting location, having traced a complete path around Jupiter's auroral ring. The realization of completing the loop around such a cosmic giant would be overwhelming and unforgettable. The traveler would log the time, roughly 4 days, assuming stable speed and safe navigation. Though only a hypothetical scenario, it demonstrates the sheer size and power of Jupiter's magnetosphere and the magnificent aurora it generates. In the end, circling Jupiter's aurora is more than a physical journey. It is a voyage through the raw forces shaping our solar system. It would show how small humanity is, and yet how far our curiosity can carry us into the unknown.